Hi, for my MINTEQ Special Project, I evaluated the treatment of industrial wastewater at varying fly ash doses, and this was based off a scientific study published in the Journal of Environmental Treatment Techniques entitled Removal of Total Dissolved Solids and Total Suspended Solids from Industrial Wastewater Using Fly Ash. As a little bit of background with my project, fly ash is one of the primary waste streams from the combustion of coal in boilers. And for my specific problem statement, I use bituminous coal characteristics that are general characteristics of bituminous coal to determine my amount of finite solids that I would be adding into my treated wastewater system. So I used two different dosages of fly ash, one at 15 grams per liter and one at 30 grams per liter, and use the bituminous coal characteristics shown on the right-hand side of the screen here to determine the amount of finite solids that was being added in each of these systems. As for the wastewater stream that I was using, I used an initial industrial wastewater that was highly alkaline. It was at a pH of 13, and I used MINTEQ to determine the initial wastewater equilibrium to calculate a total H value that could then be used in my treated wastewater system. So the values provided in the table on the left-hand side show the initial industrial wastewater inputs that I put into MINTEQ, and then my calculated total H is at the bottom of the screen. And then on the right-hand side, these are my inputs into the treated wastewater system. So as you can see in the second half of the table on the right-hand side, all of those solids, those are from the fly ash. And in this case, those values represent the 15 grams per liter fly ash dose. The 15 grams per liter fly ash dose was used as the starting point for evaluating the fly ash treatment because that was actually the most effective fly ash dosage that was determined in the study that I was basing my MINTEQ Special Project on. And consistent with the results of the scientific study, my results in MINTEQ did show that using fly ash did decrease the dissolved solids of the system, and specifically in this case the dissolved aluminum and silicic acid concentrations decreased proportionally with the amount of fly ash that was added to the system. So you can see that there with the aluminum and silicic acid concentrations. The blue represents the 15 grams per liter and the orange represents the 30 grams per liter, and essentially they cut in half whenever the fly ash dosage was doubled. However, this increase in the fly ash dosage had very little impact on the dissolved calcium concentrations, and then and pretty much no impact on the dissolved carbonates, iron, or titanium hydroxide species that were present in the system. And I presented these ones here because they were the most significant solids that were present in the final system to be evaluated. So as for the pH, the fly ash additions also decreased the pH of the system. However, the magnitude of the pH change also decreased whenever the fly ash dosage was increased. This was actually consistent with the results of the scientific study that was published and used as my basis. Essentially, they evaluated fly ash doses over a wider margin of fly ash doses, and essentially with each of those, once they reached the pH kind of hovered around the same amount, and actually the fly ash dosage of 15 grams per liter was the most effective in decreasing the pH of the treated wastewater system. So overall, based off of my results from using this problem as my basis in MINTEQ, I was able to confirm that using fly ash as a treatment method for industrial wastewater does decrease the dissolved solids concentration and pH in the wastewater because the formation of the metal hydroxide precipitates consume a lot of those dissolved metal solids that were initially in the solution. However, the effect on pH as a whole is limited, and provided here are all of my output results at the 15 grams per liter and 30 grams per liter fly ash dosages. And these are all of the species that are present at the final equilibrium of the treated industrial wastewater system. Thank you.